When we multiply and divide rational expressions, we're going to relate it back to multiplying and dividing fractions. So I just want to quickly remind you about how to multiply and divide fractions, and also remind you of what we did with simplifying first before multiplying. So if I have something like 16 over 15 times 3 over 12, I could go 16 times 3 and 15 times 12, and then reduce. Or I can reduce first, which is what we're going to want to do, because it's what we need to do with the rational expressions. Otherwise, it just gets crazy complicated. So we need to do the simplifying first. So for this, I can look at the 16 and the 15. Do they have a common factor? No? 3 and 12? Yeah, what's their common factor? 3. So if I divide 3 by 3, I get 1. And if I divide 12 by 3, I get 4. So now I have this 1 over 4. There's actually more simplifying that I can do, though. What is it?
16 and 4.
The 16 and 4. I can also reduce. So divide those both by 4. 4 divided by 4 is 1. 16 divided by 4 is 4. And I end up with, on the top, 4 times 1, which is 4. And on the bottom, 15 times 1, which is 15. So this is just equal to 4 over 15. I didn't have to know what 15 times 12 is to be able to simplify this. But if I didn't simplify first, I would have had to do that. So it's just 4 over 15. This second one is a division. It might look like subtraction from where you are, but it's actually a division. 1/2 divided by 6 over 5. What do I have to do first with this one? Take the reciprocal and change it to a multiplication. Don't try to reduce first when it's a division. First thing we're going to do is change it into a multiplication. And then we don't have to learn rules about division. We just have to do the same things we did with multiplication. So I'm going to change this to 1/2 multiplied by 5 over 6. The first fraction stays the same. You take the reciprocal of the second one. Now it's a multiplication question. So it's just like the one we did before. Is there any reducing you can do? No, for this one there's not. The 2 and 6 have a common factor, but they're both denominators, so you can't reduce a denominator with a denominator. It has to be a numerator with a denominator. So I'll just do 1 times 5 and 2 times 6, and I get 5 over 12. And what you'll notice, if you did all of that reducing first, you don't have to reduce in the end. A rational expression is like this, where it's a fraction, but it has variables in there. So this one is 12m squared f over 5cf times 15c over 4m. We need to look for a common factor in the numerator with one factor in the denominator. So I might start with the 12 and 4. 5c? Okay. Yeah, I'm going to keep those separate, but you're right. I'll just do the 5 and the 15. What do they have in common?
5.
5, so divide them both by 5. So that's a 1. And the 15 becomes a 3. And then the 4 and 12 have a common factor of 4. So that becomes a 1, and that becomes a 3 as well. And then, Ben, you said C is also common, right? So there's a C in this numerator, and there's a C in this numerator. Or sorry, in this denominator. One in the numerator, one in the denominator. So they can cancel. Really, you're dividing both the numerator and the denominator by C, and they change into ones. So we say that they cancel. They're not really just canceling. They're turning into ones. What else? F, because there's an F in the numerator and an F in the denominator. M, there's an M here, and an M squared in the numerator. What does the M squared turn into? Just an M. Yeah, so I'll just cross off the squared. So that's a lot of crossing off and whatever. I think I'm going to rewrite what we have before I do any of the multiplying. So I actually have on the top here is 3m, and on the bottom it's just a 1, right? And over here I have, what's left on the top? Just a 3, and on the bottom, a 1. Okay, so I can multiply 3m times 3, 9m, over 1 times 1, which is 1, which I'm not going to bother writing. So it's just 9m. And what else do I need? Non-permissible values. So here, anybody know what they are? 0 for what? C cannot equal 0. F cannot equal 0. M cannot equal 0. Anything that was in the denominator, any variable that was in the denominator, those factors have to give you a non-permissible value. And here, because they're just monomials, it's just zeros, right? So, what do you think of this? Yeah, what do we have to do? Factor, right. First step is factor, well, everything that you can factor, basically. So I'm going to start with that a squared minus a minus 12.
That's a multiply.
That's a multiply, yeah, that dot means multiply. So this is going to be a minus 4 and a plus 3. Does that look right?
Yeah.
And on the bottom, oh, what's special about that?
Difference of squares.
It's a difference of squares. So I can just take the square root of both terms, and we get a plus 3, a minus 3. And then I'll do the same thing in the second fraction. Factor those. I think that's going to be a minus 3, a minus 1. And then the denominator of the second one, just take out a common factor, and it becomes a times a minus 4. All right. What I need to do next is look for common factors.
There's like a minus 4 on both sides. Would I do that? Would you?
The a minus 4 is a common factor, yeah, because there's 1 in the numerator and there's 1 in the denominator. What else? A minus 3, 1 in the numerator, 1 in the denominator. And a plus 3, 1 in the numerator, 1 in the denominator. So we're left with a minus 1 over a. Can I simplify that any further? Yeah?
Oh, it would be negative 1 over 1.
Is the a common factor?
No.
No. Why not?
It's a term.
Yeah, it's with the negative 1. A is a term in the top, it's not a factor. A minus 1 is the factor. So you can only cancel those a's if a is a factor, so it's not added or subtracted to something. So that's done, except then we need the non-permissible values. What can a not equal?
4.
4, yep. 3. Negative 3, so I'll just say plus minus 3. 0. There are 4 non-permissible values. There were 4 factors in the denominator. A plus 3, a minus 3, a and a minus 4. So that gives you those 4 non-permissible values. Here's another one. X squared minus 6x minus 7 over x squared minus 49 divided by x squared plus 8x plus 7 over x squared plus 7x. What do you think you should do first?
Flip it.
Flip it, yep. Take the reciprocal of the second one. Before you even bother with any of the factoring or anything, I'm going to change it to a multiplication question. So this becomes x squared minus 6x minus 7 over x squared minus 49 multiplied by, I'm actually going to change that to just a dot so it's not confused with the x's. And then I'll do x squared plus 7x over x squared plus 8x plus 7. Now it's just like the question we did before. It's just a multiplication question. So start factoring. x minus 7, x plus 1 for the numerator, x minus 7, and x plus 7 for the denominator. And then the numerator over here, I can take out an x and an x plus 7. And then in the denominator, x plus 7, x plus 1. X minus 7, x minus 7, those will cancel. One in the numerator, one in the denominator. X plus 1 and x plus 1, because one's in the numerator and one's in the denominator. And then the x plus 7, I have 3 of them there, but I can only cancel 2, because I can cancel one that's in the numerator and one that's in the denominator. And it really doesn't matter which one in the denominator, so I'll do that. And then we have just x left on the top, right? And x plus 7 on the bottom, and Lance, that's what you said, right? Okay. Now this is interesting. Well, okay, I find it interesting. You might. When we start talking about non-permissible values here, what are the non-permissible values?
7.
Positive and negative 7? And negative 1? Anything else? We got a 7 from this first factor here, a negative 7 from here. We already used the negative 7 and the negative 1, but there is one more non-permissible value.
49.
Nope, 49 is okay because that's squared, right?
0.
0, yeah.
I said.
Why,
though, is it 0?
Yeah.
Right. When we're dividing, we have to consider more than just these two denominators here and here. We also have to consider this. Because it was flipped. This whole thing is a denominator, right? Because it's all divided by that. So when you're dividing, you need to get your non-permissible values in that factor step from the denominators and the numerator of the second fraction, because that one used to be a denominator.